This is going on page 86 when we are done. Okay, so you have been calculating things in radians since like 6th grade. You just don't really realize it, and nobody said that, and you probably haven't looked at it that way. But in like around 6th grade, it could be 5th grade, it could be 7th grade, it's somewhere around there. You start learning pi, right? When you first do circumference, stuff like that, and pi first comes up. So what is the circumference of a circle? What's the formula for that? No. 2 pi r. Thank you. 2 pi r. Okay. No. Yeah, something like that. All right. So that is the circumference of a circle. Now, and you've known that forever. Nobody has said anything about radians when you first learned that. But as far as radians are concerned, 2 pi is how far around the circle? 360. It's one full rotation, right? 2 pi is one full rotation around the circle. So this is one rotation in radians. Okay. So does that make sense to you? That's one full rotation, 2 pi r. Okay. And so that means that you take the radius and you multiply it by that, and that gives you like what the actual length of the circumference is. If the radius is 1, like for our unit circle, then our circumference is 2 pi, and the radians all the way around the circle are 2 pi also. If you double the radius, then you're going to double the circumference. Make sense? So if r was 2, then your circumference would be 4 pi, and so forth and so on. So let's say that I don't want the full circumference, I just want half of it. Right? I just want half of the circle, so I would just use half of the full rotation and just use pi, right? This is what changes. We change this part right here, and that gives us just the arc length that we want. Well, this right here is driven by your angle in radians, right? That's basically 360 in radians. It's basically a conversion in there with it. So, and then what we also learned about what a radian is that it is the arc length divided by the radius. So if the radius is 1, then it's just the arc length, and that's how we got all that stuff off of our unit circle. Make sense? So if it's not a unit circle, then your radian angle is the arc length, which we use s for, I don't know why, but it's s, over r, and that gives us our angle. Okay? So does that much make sense so far? Now, if let's say, then I just want to solve for s, right? I just want to solve for the arc length. What would I do here? Okay, good. So then I'm not going to repeat that. I'm not going to repeat that because I don't want to confuse anybody. All right. So s over r, if I want to get s by itself, what would I do? Multiply both sides by r. So when you are looking for the arc length, s is equal to r times theta. It's that easy. You did arc length in geometry, but your formula looked very different. That's because we were doing it in degrees. Okay, there's an arc length formula that looks really yucky because it has a conversion factor built into it. Because it's yucky, I don't teach it that way. We look at it proportionally. But still, basically, you're converting within that. We don't need to convert if we can actually do it in radians, and everything's a whole lot simpler. Okay, so s is r theta. And this part right here is important, where theta is measured in radians. Where theta is measured in radians. So we have to have that in radians. We can't be using degrees, so you might have to convert within it. Okay? So let's look at these examples. It says, find the length of the intercepted arc, given the angle measure and radius. Give your answer in terms of pi, and then we're going to mark that out, not and rounded to the nearest thousandth. Just in terms of pi. Okay? So that's why we didn't get a calculator today. So we have 5 pi 6, we have an angle, and we have a radius. So our formula is s equals r times theta. It's just very simple to do s equals 3 times 5 pi 6. Then, of course, we would reduce 1 into 2 so that I get s is equal to 5 pi halves. And what would the units be on that? Feet. Okay, it's arc length, it's feet. Okay, length, it's feet. All right, let's jump to number 4. 4, we have 2 pi, and then we have 6.2 yards, and we're going to want it fractionally in the end, so let's go ahead and put our 6.2 into fractions. How do you properly say a decimal? The proper way is not 6.2, it's 6 and what?
2 tenths.
2 tenths, okay. So that means that this is literally 6 and 2 tenths which is the same as 6 1/5, which is the same as what is an improper fraction? 31 over 5, right? So that's our yards right there, 31 over 5, and we have 2 pi. So then S is equal to R, which is 2 pi. No, it is not 2 pi. R is 31 over 5. 31 over 5. It doesn't matter what order they're in. I just don't want to confuse you. Times 2 pi over 1. So your arc length then is 62 pi over 5. And what are our units? Yards. Okay. Easy enough? I mean, it's just substituting into a formula. You just got another formula. Okay. So now we're going to look at the ones where you have to convert to radians. And we are not using a conversion formula. Okay. Not unless it's an angle that we just can't handle any other way. So this is 15 degrees, right? So let's think on our unit circle. 15 degrees was not one of our special angles. But 30 degrees is, right? So 30 degrees is what in radians? Pi 6. So that would be pi 12ths, right? It's half of 30, so it's half of pi 6. So 15 degrees is pi 12ths. Do you see how you use some reasoning and what you know about the unit circle, not just substituting it into a conversion formula every time, okay? Sometimes that is necessary, but that is not always necessary. All right, so then that 8.4, that's going to be 8 4/10, which is 8 2/5, which is what? 42/5. Okay. Now that I've gotten fractions I can handle, then S is equal to R, which is 42/5 times pi 12ths. And then I can reduce some. 42 and 12 are both divisible by what? 6. So this can be 2 and this can be 7. And your arc length is 7 pi over 10. And that's meters. Everybody okay with that? Now the next three, we're not going to work the whole problem. We're just going to talk about what the radians would be and how we figure that out without just converting and without maybe just knowing. Maybe you know them at this point. Maybe you don't. Maybe you will never just know them and you have to think about it. Honestly, I still have to, when I went 330, I think around the circle. I don't just know them. I think I do, but then I double check myself because I'm afraid I'm going to be wrong. All right, so this 330, it's almost 360, right? So it's how far from 360? 30 degrees. What is 30 degrees? So this is 30 degrees right here. What is, it's pi 6. So all the way around is 12 pi 6. If I back up one, I'm at what? 11 pi 6. You see how you figure that out? That's how you reason around the circle and what I mean about reasoning around the circle. All right, so 120. 120 is 2 times what? 60. What is 60 in radians? Pi over 3. So if 2 times 60 is 120, then 120 is what in radians? 2 pi thirds, because pi thirds is 60. And you multiply by 2, you get 2 pi thirds. Okay? 135, what quadrant are we in? Try again. Second. We're in the second quadrant, which means we've gone 90 and how much more? 45. Okay, so this is 45. So that means your reference angle is also 45 degrees, right? What's 45 in radians? Pi fourths. So then it takes three of them to get there. There's 3 pi fourths. Okay, so do you see those steps that your brain goes through to get you where you need to be? Okay, or maybe you just know them. If you do, that's great. But again, that's not going to be everybody, okay? Or 6 pi eighths, sure. Okay, let's look at number 9. It says the central angle theta in a circle of radius 6 meters has an intercepted arc length of 10 meters. Find the measure of theta in radians and in degrees. All right, so my formula, S equals R theta.
Why can't we put this?
Because you just can't. All right, so then we don't have time to discuss that right now. So do you know your arc length? 10. Okay, so you get 10. 10 is equal to, do you know your radius? It's 6. And so then I multiply by theta, right? So I'm looking for theta. So now if I divide both sides by 6, I'm going to get 10 6 equals theta, which means theta equals what? 5 thirds. And it's 5 thirds what? Radians. It's an angle, and if I'm using that formula, my angle is in radians, so this is 5/3 radians. It does not have a pi, like there's a pi factored into it. It's just not literally the pi symbol in the question, okay? So I need it in radians and in degrees, which means in this case, there's no reasoning around the circle. You're going to have to convert, right? So if I want to convert radians to degrees, I would take 5/3 and I multiply it by what? It's either 180 over pi or pi over 180. 180 over pi. If it's radians, you need to divide the pi out. So it is 180 over pi. So then 3 goes into 3 once, goes into 180 60 times. So that means theta is also 300 over pi degrees. And that's the exact form. Okay. What questions do you have? Both of them, because it asks for both. It says in radians and in degrees. Mm-hmm. All right. Yep. Because if you needed to figure out where that was, then you would use a calculator to divide it out. But we don't need to get that far. Okay. A merry-go-round rotates. It is not a radian. It is degrees. Just because there's a pi in it does not mean that there's radians in it. All right, a merry-go-round rotates 2,808 degrees per ride. How far would the rider seated 8 feet from the center of the merry-go-round travel during the ride? So this is an arc length thing, right? Because it's just how many times have you gone around the circle, that sort of thing. But I need my angle in radians. So again, this is not a reasoning around the circle. I wouldn't try and reason around the circle on this one. I would convert. So we're going to get 2808. To convert it to radians, what do I multiply by? Pi over 180. Got to put a pi in it, right? And then I'm going to reduce some. So you don't need to sit there and figure out the biggest numbers. It's not worth your time. They're both even, so we'll knock this down to 90 and this down to 1404. And then they're still both even, so I can knock this down to 45 and this to 702. So now I have 702 pi over 45. Can I reduce that some more?
Yeah, you can.
Yes, they're both divisible. They're both divisible by 3, right? You see that? Because you can add them together. All right, so if I divide the numerator by 3, 3 goes into 7 twice with 1 left over, then 3 times with 1 left over, then 4 times. And then 3 goes into 45 how many times? 15. Okay. Can I reduce it some more? Yeah, they're divisible by 3 again, aren't they?
Yeah.
Okay, so listen, because if it's the 3 trick works with 9 as well. So when I added these together and it gave me 9, they were divisible by 9, I could have divided by 9. But dividing by 3 and dividing by 3 again, totally fine. 3 goes into 23 7 times with 2 left over. So then that's 8 over 5. So I get 78 pi over 5. That's my angle in radians. Okay? And that kind of number manipulation is something you need to be able to get better and better and better at and quicker. That's why I keep the calculators out of your hands as much as possible. 3 and 9, yes. So if it's just divisible by 3 and not by 9, like when you add them together, then the number is divisible by 3 and not 9. But if it's divisible by 9, then you can just go ahead and divide by 9, both of them. Okay, so that means now that I need to do S is equal to R, which is 8, that's their radius, right? Times theta, which is 78 pi over 5. Okay. So I need to multiply 8 times 78. You've got a couple of options there. I would probably do 8 times 80. What's 8 times 80? 640. But then I didn't really want 80 of these, right? I only wanted 78, so I got to subtract 2 away. And that means that that would leave me with 624 pi over 5. And what are my units here? Feet. What questions do you have? All right, so let's look at 11. Cincinnati, Ohio is directly north of Atlanta, Georgia. Cincinnati has a latitude of 39.1 degrees north, and Atlanta has a latitude of 33.7 degrees north. If the Earth has a radius of 3,960 miles, how far apart are these cities? Okay, so if we think about looking at this as like a slice of the globe, right? And here is Cincinnati, and here is Atlanta, because that's directly north, right? Then we've got these two latitudes. I need to know the angle between the two cities, right? So how do I figure out the angle between the two cities?
You get the radius RS. I mean, S is equal to R.
No, stop yelling things out and think. I know the latitude of each one. If I want the actual angle between the two,
Oh, you add those and you subtract it from 2 to 5.
I just subtract them. That's all. That's all I got to do is subtract them. Don't try and get crazy, okay? Because whatever this is, and this is like at 0. I shouldn't have done it that. I shouldn't have probably done it that way. Let me do it this way. Let's just pretend like, oh, that's at 90. My picture is just bad. That might have confused you some. Hang on. Let me start over on my picture. Okay. Oh goodness. Let me start over. Okay. So maybe it's more like here and here. Okay, not at 0 and 90, that sort of thing. And they're really not even that far apart because the Earth is ginormous. But if I just want the angle between the two, this is an angle from 0, and so is this. I just subtract them to figure out the angle between them. That's all I got to do. It's just subtraction. So I'm going to take that 39.1 and subtract the 33.7. Very complicated way. It's just a simple subtraction. When I subtract, what do I get? 5.4. Okay, so this is 5.4 degrees, right? It is not a length of anything. It is an angle. Remember that little video I showed you about latitude, longitude? Okay, it's the degree there. Okay, so this is 5.4 degrees. So that means that this is 5 4/10, which is the same as 5 2/5, which is 27/5 degrees. We agree with that? I need to convert that. I need to convert that to radians. So what do I multiply that by? Pi over 180. Okay. 27 and pi are both divisible by what? 9. So this is 3. This is 20. So my angle in radians is 3 pi over 100. Okay. They're both divisible by 9. I said pi. Okay. I don't know what I said. Whatever. That was the one thing that Michael was paying attention to, so I don't know. Like, when I mess up, that's what he catches. All right, so we have theta. Do we all understand how we got theta? Okay. So now I've got to find the arc length, because that's going to give me, I found the angle, I need to find the actual distance. So S is equal to R, which is 3,960 times 3 pi over 100. So then I can easily divide them both by 10 and knock out the zeros, right? And then I can also divide those both by what? It's either 5 or 2, yeah. 2. So this is 5. 396 divided by 2 is what? 198. Okay. So now I'm just multiplying 3 times 198. Can I do 3 times 200? Yes, that gives me 600. Then I subtract what? 6. So this is going to give me 594 pi over 5, and this is miles. Okay. Number manipulation is super important skill. Okay. What questions do we have? All right. So let's look at this. So what if, well, okay, what is the area formula for a circle? Pi r squared. This one is pi r squared. Okay. So what if I told you this one also had that radian conversion in there, and that's not really the area of a circle. Okay? No. So where this comes from, so this is area of a circle is equal to, it's actually 1/2 times 2 pi times r squared. But then it simplifies, okay? That's why we just use pi r squared, because it comes from that. Because it's really coming from the area of the sector. Now this is the whole circle. We go all the way around the circle. That's why it's 2 pi. That's our radians right there. Okay? Does that make sense to you? That's 2 pi radians. But let's say I didn't want to go all the way around the circle. I just wanted the area of this sector right here. So instead of 2 pi, I want whatever that angle is right there. Does that make sense to you? That means that the area of the sector is actually equal to 1/2 times theta r squared. And if the sector is the entire circle, that's where you get pi r squared from. Okay, and again, where theta is measured in radians. All right, so let's start with number 13. And I'm going to adjust some of these numbers. Some of these numbers I'm adjusting on your assignment too. So once I give out the assignment, make sure you pay attention to what you actually have to change. Otherwise, some of this math is going to be a nightmare for you. We're going to change 205 to 210. Okay? No, I'm going to give you numbers to change. You don't get to randomly change them. All right, so let's think about that 210. I need that in radians, right? 210 is in which quadrant? The third. So that means I went 180 and how much more? 30. What is 30 in radians? Pi 6. So in the third quadrant, this would be 6 pi 6. I go one more, and what is that? 7 pi 6. So that is my angle in radians, and that is your reasoning around the circle. Okay? And then we're also going to change this 11.2 to 12. Because the intention of me not making you not get a calculator is not to make the numbers horrendous, but for you to practice some of those skills. So I'll give you decent numbers to work with. So now I just substitute this in. I get area is equal to 1/2 times 7 pi 6 times 12 squared. And I'll put that over 1. Now, what's 12 squared? 144. You know that, but you don't even need that here. If you jump in and you just start squaring things and multiplying everything together, you're going to make your life very, very difficult on some of these. Look, remember, we want to think smarter, not harder. What is 2 times 6? 12. So that's going to take care of one of those 12s, isn't it? So I didn't need to square it. So now all I have to do is multiply 7 times 12. What's that? 84. So this is 84 pi feet squared. You see how that works? Work smarter, not harder. Okay. All right, look at number 14. No, so these numbers are already okay and decent. I'm already in radians, so I'm good. So I get area is equal to 1/2 times 2 pi thirds times 7 squared over 1. Then I simplify first. These 2's cancel out. Is that 3 going to do anything with those 7's? Nope. So my area is just 49 pi over 3 kilometers squared. Okay? All right, so 15, we're going to change this radius to 24. All right, so that means I get area is equal to 1/2 times 19 pi over 12 times 24 squared over 1. And you finish that one up. Yes, really. Good. Even when I mess up and say weird things, we're still on the same wavelength, apparently. Okay, so we got to multiply 19 times 24, and how you do that is up to you. If you want to write it all out and carry and add and whatever, but trying to process through a quicker way for yourself is not a bad idea. What questions do you have at this point? None. Awesome. Let's look at number 16. It says, the area of a sector of a circle with a central angle of 240 degrees is 134 feet squared. Find the radius of the circle. Okay, so we want to find the area, or area is equal to 1/2 theta r squared, right? But I need theta in radians. So 240 is in which quadrant? Third. That means I go 180 and how much more? 60. Okay, 60 in radians is pi thirds. This is 3 pi thirds. I go one more. It is 4 pi thirds. Okay. Don't need to do the whole conversion thing on that. All right, so now I substitute stuff in. Do I know the area? Yes, I do know the area. It is 134. That's equal to 1/2 times theta, which is 4 pi thirds, times r squared. So I can start by reducing. This makes this back down to 2 pi thirds, right? Then I need to get 2 pi thirds away from r squared. So I can multiply both sides by 3 over 2 pi. 134 over 1. That equals r squared, right? So 2 goes into 2 once. It goes into 134 how many times? 67 times. So then in the numerator, I'm going to have 3 times 67, 201. So I get 201 over pi. That's equal to r squared. Then what do I need to do? Square root. So r is equal to the square root of 201 over pi. What are the units on this? Feet. And this is an exact answer, right? Because you didn't have a calculator. If you need the actual number, you type it in. That is your exact answer. It's not your Home Depot answer, right? If you needed to go get a board cut that many feet, you don't walk into Home Depot and say, I need the board square root of 201 over pi. They'll look at you like you're crazy, right? You would type it into the calculator, get your values, then you know what it needs to be, okay? But we just don't need to get to that point, okay? What questions do we have? We're good? Awesome. Let me give you your assignment, and then I'm going to put up here, actually, I'll go ahead and, the first thing that you're going to do when you get it is change. Once it changes, there you go. The very last question on the front, both of the times that it says minutes, change that to hours, and then there's more on the back that you're going to change. Tomorrow, I'll probably give you 2 minutes tomorrow as well. Okay, so number 10, change minute and minutes to hour and hour so I can turn the page. And on any of these that say, I don't remember if I changed it on the assignment or not. Did I? No. Yeah, all these say and to the nearest thousandth. You ignore that part too. All right, on the back, this is what you're going to change. All the way down to number 17, okay, down here. And there's nothing past that, so like this is it. If you make all of these adjustments on your assignment, then your numbers won't be as bad. And you may not be able to read them if you write them on the inside. I don't know, because I know it's shaded kind of dark, but okay, there you go.